Welcome back to another exciting chemistry lesson. Well, in the previous lesson we learned about acid and base. Now, in this lesson we are going to look at how they react together to neutralize each other. In titration, you basically can use this method to identify the concentration of an acid or a base based on specific values that's given to us. What other terms are being used in titration? That is, we use the term neutralize. That is, a base neutralizes an acid. As you can see in this chemical reaction, you have this acid react with a base. You can see the hydrogen here and the OH right here. We are talking about strong acid and strong base. Now, even a better term is this right here. That is, in a strong acid and strong base, they completely neutralize each other. So those are the terms that we use to describe titration between acid and base. Again, this is only for strong acid and strong base that completely neutralize each other. We will work with weak acid and weak base. That is a completely different story. As you can see here, look at this right here, hydrogen and BOH. Not all acid will have just one hydrogen and one OH. And that's why we add this in here, N and M. So we already learned how to do this already. Remember in the back all day when we have M1 times V1 equal to M2 times V2, and we're talking about in terms of dilution to determine the unknown concentration of volume. Now in this case we do the same thing but relative to acid and base, and of course we add in the M because again it's not always 1-to-1 ratio. So N is for the number of hydrogen, where M is the number of OH right here. So we are going to look at that more carefully. And M just for concentration. Notice how we have A and B. A is for acid, B is for base. And volume, this is where it gets really tricky. Volume, remember, because we use this equation, we don't have to worry about converting our volume to milliliter to liter. We just have to use whatever is given to us. The key is that they are consistent or the same on both sides. So that's the logic of using this equation. So make sure you memorize this, okay? Very important. It makes your life a lot easier. Then let's look at an example problem. We have 20 milliliter of HCl, which we know is hydrochloric acid. So that is right there. If you don't remember what it is, this solution is completely neutralized. Notice how we use the word completely neutralized. So it doesn't really matter if you remember a strong acid, strong base. If they give you the word completely neutralized, this allows you to use that formula right there. Okay, that's the very key right there. By 30 milliliters of a 0.25 molarity NaOH, what is the concentration of the original HCl solution? So by having this term right here, we are able to use that. So let's write it out. We have N MaVa equal to M MbVb. There you go. Just plug it in. As you can see here, we just have one hydrogen and one OH right there. So let's plug it in. So what we have here for the acid, we just have one hydrogen, okay? For the Ma, we are looking for it, okay? So Ma. And then for V, we have 20 milliliters. Again, we don't have to worry about converted to liter. That's the beauty behind this equation. And then for the base, right there, we just have, look at that, beautiful, isn't it? We just have one. And then for the Mb, we just have 0.25, okay? And then for the volume, we just have 30 milliliter. So we multiply, okay, multiply, we can ignore the 1, of course, 0.25. So we know that we can multiply, right? So we have 0.25 times 30. We have 0.25 times 30. There you go. And then we can take our answer and then we can divide it by whatever over here. Okay, basic algebra, divide by 20. Again, we can ignore the 1. So our answer is 0.375. So in this case, Ma is equal to 0.375 molarity. And that is for HCl. That is all we have to do. We don't have to write our balanced chemical equation. It bypasses all of those, okay? Let's try another problem. Here we have the same situation right here, right? But it's neutralized with BaOH, okay? And notice how we have 2 right there. What is the concentration of HCl? in the original solution. So again, same thing, okay, and plug it in. The HCl only have one H, so we just one. Ma, we are looking for as well, Ma, okay, and V, we know is 20 milliliter. And then over here for the base, look at that, because of BaOH right there. See that right there? Because that 2 right there, we put a 2 right here. And what's the molarity? The same molarity. I just want to use the same value to demonstrate how the problem changed based on the values of, okay? So now we have V, which is 30. Now let's plug into our decimal calculator. We have 2 times 0.25 times 30, okay? Enter. And divide it both on this side, okay? But before we do that, we need to bring down the answer divided by 20. There you go. So there you go. Our answer in this case, now it's changed. Our values, right? In this situation, we have Ma equal to 0.75 molarity of HCl. There you go. And the cool thing about this is once you have molarity, you can convert to mole and you can do anything with it. Now let's try another problem. Very similar situation, but in this case we are given molarity of HCl and neutralized by the same base again, okay? So what is the volume? As you can see, this is the same problem, and we should expect our volume to be 20 milliliter because it's the same problem. In the other problem we solved for molarity, in this problem we solved for the volume. So let's plug it in, okay? So we have, again, so in this case let's plug it in. So again, N MaVa equal to MbVb. Okay, let's plug it in. And for the acid, it's just 1 because we only have 1 hydrogen there. And the molarity is 0.75. For the volume, we don't know. And over here, we have 2 right there. So 2 molarity is 0.25. And for the volume is 30. So let's plug into our decimal calculator. We have 2 times 0.25 times 30, okay? See how that works? Just plug it and divide it by on this side, okay? Divided by, well, put answer divided by 0.75. There you go. And look at that. Our volume is 20 milliliter. See how this is so much easier? You don't have to worry about writing out balanced chemical equation. It makes your life so much easier, okay? Now let's try another problem where in this case we have this right here, sulfuric acid with the 2 hydrogen, okay, neutralized by KOH. Okay, what is the concentration? Well, in this case, I'm asking for the concentration of H2SO4. I forgot to change that in the problem. There you go. Now let's look at this problem. Same concept right there. There you go. In this case, our N is not going to be just 1. Our N is going to be 2 because of that 2 hydrogen there. So now let's plug in our molarity. Well, we are looking for it. So Ma, and our volume is 20 milliliter. And then for M, in terms of base, we only have 1. So it's 1, okay? And our concentration, again, it's the same thing. 0.25, make our life a lot easier, okay? And then we have 30. Here you go. Now all I can do is just plug in the decimal calculator. There you go. So we have 1, which we can ignore. 0.25 times 30, okay? Enter, bring the answer down, divide by on this side. We have divided by 2, okay? And then we divide it, and then enter, bring answer down, divided by 20, okay? There you go. The answer is, okay, so our concentration is equal to 0.19 molarity of H2SO4. So that is how you work with titration between acid and base that are completely neutralize each other in order to figure out how much volume do we need or what is the concentration of a specific acid and base going to be.